Hey guys, I'm going to show you in this presentation how to go ahead and name binary ionic chemicals. And binary means that they're made of just, again, two particular elements. So as you see here, they are a combination of just two elements. The idea behind naming ionic chemicals of this type is that the first element receives its normal name as it would be written on the periodic table. The only new little tidbit is that the second element, in the formula, has its ending changed to "ide" in its name. So some of these may seem familiar in terms of how we name them. Okay, so let me go ahead and illustrate here on something that we've consumed on the daily. Okay, and that is sodium chloride. So Na, is our element sodium. Okay. Now, NaCl isn't just sodium chlorine. When it is involved in this chemical, we call it chloride instead. So you guys can see, instead of the INE at the end, it becomes IDE. Okay. Likewise, when we're dealing with this next example, with Ca and O, you are going to name the first element normally calcium. Does a body good. And oxygen, changes its ending to oxide. So calcium oxide there. And then down here, Al2S3, Al gets its normal name, elemental aluminum. And then sulfur becomes sulfide. And if you do get kind of tripped up and want to check your endings, in this ion list, I provide it, what they do for you is they do show it to you in the IDE endings there, but you can also see it show up on this section of the table as well on reference page 2. So we'll look at a couple more of these in a special case. Just be careful when you see transition metals. When you see transition metals, they should be a red flag for you. There's our red flag. Because what you got to do is you got to specify the charge using Roman numerals. So to do this, you're going to still treat this like a normal ionic chemical, binary in nature. So you're going to name the first element normally. So we got iron, and Cl, chlorine becomes chloride. Now, you got to figure out what charge iron has here, and to do that, you'll look at what it's attached to. Well, that's a 2, So you're probably using a +2 charge, but you got to double check things because sometimes it will simplify out. Well, chlorine happens to have a charge of -1. So nothing simplified out here. So your final formula is going to be iron, Roman numeral, 2, chloride. Because you're using the +2 charge. Likewise, for the second one, and here's a little tricky one, nickel. Nickel is a transition metal. So you're going to write nickel. And oxygen becomes oxide, right? But nickel does have more than one charge. Now I said look at the elements attached to it. Right now it says that it's really a 1. But if you look back at your ion reference sheet going down to nickel, look here. Nickel has a +2 charge. Additionally, if you look down over on this side, sorry that it's sideways, it has 2 charges, 2 and 3. Well, if you look here, whatever oxygen had, it was simplified out. So this will tell you, that you are dealing with, a +2 version because it balanced out the oxygens -2. So you're doing nickel, Roman numeral 2, oxide. You can check this out by actually writing the